The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, an award-winning podcast where we reach into the core of the .NET technology stack and, with the help of the .NET community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform multi-application frameworks on the planet. I am your host, Jamie Gaprogman-Taylor. In this episode, I talked with Matthew Jeorrett about the clean architecture, subcutaneous testing, and how he utilized both to build the My Bookinghub web application in a clean, vertical, extensible manner. Along the way, we discussed the many positives of mentoring and sharing your experience with other developers, regardless of where they are on their journey. We also talk about how it is not possible to know it all, and that by listening to others who are sharing their experiences, you can adapt and learn. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. Thank you ever so much, Matthew, for spending some of your evening with me. I really appreciate it. The nights are drawing in. Everybody wants to spend time indoors. I mean, we're all spending time indoors anyway, but we all want to spend more time away indoors, preferably away from the computer because that's healthier. So I really appreciate you spending some time to talk to me today. So thank you ever so much.
No problem at all. It's good to be on your show.
And welcome to the show as well. My goodness. Okay, so I'm not going to dilly-dally too much. We talked earlier about clean architecture and subcutaneous testing, so we'll maybe cover those a little bit. There's also some new stuff you want to talk about as well. So why don't we start with a little bit of an intro to yourself? Is that all right?
Yeah, sure. Yeah, so I guess I'm not a lifelong software developer. I studied architecture, and that's like building architecture, not software architecture. And I worked in property for a number of years, about 6 or 7 years. And then through Code Clan, I kind of got into software development. They taught me just enough to be dangerous. And then I got my first job as a startup working with blockchain technology, actually. So that was like a bit of a baptism of fire. Worked there for 3 years. And then I moved on to Clear Sky Logic, where I am today, working as a tech lead and lead developer on their booking platform, My Bookinghub. 5 years in, and I'm loving every day of it.
I can't imagine being a journeyman developer, at the beginning of your career, jumping straight into blockchain. That must have been, like you say, a baptism of fire. That could not have been easy.
No, it was coming out of Code Clan. They obviously teach in certain technologies, so Java and React were the kind of two frameworks and languages that they used. And then moving into wallet services, they build in .NET and C# and Angular. So as well as the blockchain, everything else was different as well. So it was quite challenging, but I had a ton of support and learned quickly, so it was good.
I love to hear about people getting support when they start new jobs or new technology or a new project. It's always super important to do that because you don't know the domain. And then, like you say, you maybe don't know so much about the framework, or you don't know so much about the front end. Most people won't hear it that I'm going to shout out to, but I do want to shout out to those devs who will take the time to sit with someone and say, "No, it's cool. Don't worry about it. Let's just talk through it," because that's what you need. I've been on this journey of software craftsmanship, and after having read The Pragmatic Programmer about how to be less, I guess, enthusiastic. No, not enthusiastic is the wrong word. Evangelical, I suppose. I'm worried about that term, but you get the idea, right? When people say, no, React is the best, no, Angular is the best. And I'm like, whatever fits the bill. You two can stand here and scream and shout about React does this and Angular does that. Or we can get the work done, because we're not being paid to scream and shout about one technology over the other. We're being paid to solve the problem. Right? The CEO doesn't care which technology it's written in. They just care that when they hit the button, they somehow get money out. That's literally it. They are so far removed. All they care is they get the money, right? So let's not worry about it too much. So yeah, I really appreciate that you were given that support. That's one of the most important things, especially someone who's towards the beginning of their career and someone who is, like you said, working in a new technology, new domain. So that's wonderful to hear.
Yeah, 100%. And even experienced developers, you might know the stack well, the technical aspect, but you won't know the domain. So when you join a team, you won't know the product, you won't know the domain, and there's a ton of learning to be done there. And there is no substitute for just sitting down beside someone and talking through it. No amount of documentation or well-structured code or clean code can substitute just sitting down with someone.
Absolutely. And that's why the writing of the code is maybe 35-40% of the skills required. The rest of the time, because you're going to be doing even less of that when you actually do the work. Most of the time you're planning, you're debugging, you're reading, you're working with other people, and it's that ability to communicate and the empathy to be able to sit with someone else and say, look, I don't quite get this, can you explain it? Or to be on the other side when somebody sits with you and says, I don't quite get this, can you explain it? Because both sides of that conversation are incredibly difficult to manage, especially if you're new to the business, because there's this feeling that, we have to know everything, we have to know it all. And guess what? You're never going to know it all. There's a person who's pretty big in the .NET space called Scott Hanselman, and he's been doing it for 20, 30, however many years. And he says, I don't know it all. I haven't got a clue. There's a whole blog post about how when he was sitting with two juniors and they were figuring out how to draw an X for a close modal button. And one of them was like, well, we need to pull in all of Font Awesome. And the other person was like, no, we need to pull in all of this library. And these other people kept coming over and giving loads of examples. And he went, or I could just type an X, right? And the idea behind the example that he gave there was that it was like there are so many millions of different ways to solve a problem. You're never going to know how to do it with all the technology. And that isn't meant to be a negative. That's supposed to be. Let's celebrate that. That's a positive, right? Because there are so many ways you can experiment and explore, and you'll meet people who have completely different paths through their development journey, and you'll be able to go, oh, cool. So tell me about what's Go all about. Oh, what's Python? Oh, cool. I know enough about Python, for instance, to know that it's a machine learning thing, but what's that all about? Java. I know that's quite similar to C#. A lot of people like to say that it's not, but it is quite similar to C#. Let's talk about that. Let's figure this out. Because it's only by the cross-pollination of those ideas that we'll ever get anywhere, right?
Yeah, 100%. Yeah, it's something that I've been thinking about recently, is this idea that talking about the different ideas, it's a really important step in solving problems, is that you cast the net wide and see, well, okay, it feels like this is a good way to solve the problem, but let's think about what the other options are, and then we'll pick the best one rather than getting tied to, let's do it the quickest way that we can. And part of that is getting different people on board who have those different perspectives, because I find it incredibly difficult myself if I'm solving a problem. Once you've got that initial idea, we could solve it this way, to get away from that and go, actually, what other options are out there? So I think that's where one of the ways collaboration is super important, is that diversity of ideas before you settle on how you're going to do something.
Absolutely. And I feel like you hit upon something there. There's a real skill involved in, like you say, I have this idea for how to solve the problem, but I need to be able to step away from that and try and look at it from a 10,000 foot view, or maybe you want to say 6 months from now view or something, because it may solve the problem now. And that's great. But then in 6 months' time, when all of the requirements change, does it still solve the problem? And another question, does it matter? Right? Because in 6 months' time, it might be a completely new code base written by completely new engineers. We have to, I feel like in the world in which we live in, the speed, the agility, I feel, pardon the expression, because I'm worried now that people who are not fans of Agile are going to turn off. I don't mean as in Agile, the process, just the agility, the speed and direction in which, the velocity in which we make our software. It changes so quickly. You can literally be on a project now, and in 6 months' time, it may indeed be a completely different code base, or it may be exactly the same code base, but with completely different modules, right? And so I think that being able to make that decision of it solves the problem now, fantastic, but can it be extensible enough in 6 months' time? But then also, like I said, does it matter whether it's extensible or not? Because will it be replaced in 6 months' time? It may be that the module, the thing you're working on, is get it sorted now and then get it out the door, and we will incrementally, accept that tech debt, but then we'll replace it in 2-3 months' time when we get a better handle on the when we get a better handle on the problem. Because sometimes even the people who write the specifications, they don't know the real problem. Sometimes even the end client, the end customer, the end user, they may not fully understand the problem. And so it all has to, like you say, it's all a collaboration. It's working with the other people on the team, working with the managers, working with specification people, the architects, the users. That's what it's all about. Get everybody involved and just keep those ideas flowing. Because otherwise you're going to sort of stagnate, I suppose.
Yeah.
You'll get to a position where all you know how to do is build .NET stuff with Angular or Java stuff with React, or you tie yourself down to a handful of technologies, and then you ended up having to sort of shoehorn a solution into the problem, if that makes sense.
Yeah, I think software is a funny combination of transient, cheap, like software is cheap to write and cheap to run, but at the same time it's got a degree of permanence. If you've got a successful system, then a lot of what you write will be permanent for a while. And it'll be around for years to come, and people will have to deal with it. And so understanding when something doesn't really matter or when it does is super important. And I guess that's kind of where having a strong architecture in place that allows you to fit things within a framework that is flexible to change is really important.
I agree completely. And I suppose that's where loads of different ideas around architecture have come in, and where we've got like microservices versus monoliths versus functions versus containers versus this, that, and the other. And it's how do you figure those things out, right? it's for the smarter people than me to answer that question. I haven't got a clue. Like you say, pick the thing that solves it right now, and hopefully you can build it in such a way that people can come in and add things to it, right?
Yeah, it's when looking at the kind of landscape of architectures and writing out there, I think one thing you start to do as you become a bit more experienced is that you look at it and you find the common themes amongst it. And it's not about clean architecture versus hexagonal architecture versus whatever. It's about the themes about decoupling and flexibility, and it's sometimes easier to pick a thing and hang your hat on it and say we're doing that. But ultimately, it'll be your own version of that. Like everyone does Agile, but they do their own flavor of Agile, and they don't do this ritual, but they do this one differently. But the important thing is that you kind of understand the principles, and they're expressed in different concrete implementations. But ultimately, you'll put together, compose your own version of that, and hopefully come out with something that works.
And that's what it goes back to, that collaboration thing, right? I'm going to pick on Agile, right? I'm going to pick on Agile, and I'm going to say that things with Agile, Scrum, RAD, extreme programming, that kind of thing, they're not meant to be rigid sets of you must do this, you must do this, you must do this. It's take the things that work for your team, take the things that work for your project, take the things that help you to deliver that thing on time, and use those. And then take the things that help you to react in such a way that you can change direction, you can pivot, you can reprioritize. That's all it is. It's not necessarily a here are the 50 steps to Agile making loads of moneyness. That's not a great way to put it. But it's not a case of these are the 50 steps of follow these steps and you are guaranteed to always release your software on time. It's a case of pick number 1 for an 8 and see how that goes. And if that doesn't go well, swap number 4 for number 5. If that doesn't go well, swap it for number 6. It's all mix and match. Let's just figure it out.
Yeah, I think a really powerful idea in software and is principles. So principles are about not this is the right answer all the time, but it's a tried and tested thing, and 95% of the time it's right. And it's like a direction that you travel in. So Agile has got its principles. Like the top level, you've got people over process, and that's like a fundamental, exactly what you're saying. It doesn't matter what process you follow, it's about making the people effective, and the process supports that. And on the technical side with architecture, it's about the principles guide how you build the system, and consistency over correctness is something I come across so many times recently. It's about, well, we've got this approach. It might not be 100% the best approach, but actually it's proven, it's tried, tested and proven. And so unless you've got a really good reason, let's keep it consistent and head in this direction so that we don't have to solve kind of transient, the problem about there's 100 ways to solve this, which one should we pick? It's like, well, this is the way we've chosen, this is the strategy here, and let's focus on the real difficult problems, like the novel things that we have to do.
Totally. And the scary thing is, right, that if you think about it, our industry has really only been around for around 70 years. I'm not going to count, although they were complete pioneers, I'm not going to count pre-World War II, because that was a machine was built to solve one problem. The idea of the stored program computer came about in the 50s. So we're 70 odd years into this industry, and we are right at the front of figuring it all out, right? I've got friends who are, the sort of senior because they are old enough to be senior, and they're like, one of my friends, I want to say he's in his 50s, and he's like, I've been working in software for half of its life, not half of my life, half of its life.
Yeah.
We are at a point where we can have people who are that age and talk about that. So what I'm trying to get at is, we are still in the sort of figuring everything out stage. We're still at the very early stage. If we were a physical engineering, we'd probably still be, Roman era times, We are right back at the beginning.
And I don't know if it's unique to software, but part of software's ability is that we solve our own problems. So like tooling and IDEs and CI/CD, they're all software problems that are helping to build software. And it's kind of a feedback loop, and it makes it a really interesting area to work in, that you can use your own skill set to help you do your job with your own skill set better. It's kind of, I find that really interesting. So I guess in mechanical engineering, you make tools to help you make the products, and it's that kind of idea. It's really cool.
Yeah. I love that idea of like dog fooding. You build the software and you use that software to build the next bit of software. It's absolutely brilliant, because there's no other like better test for whether your software is good enough than to say, hey, I've used my software and this is what I've been able to do with it,
Yeah, software's dead if it doesn't have users, and if you've got a genuine need for that software, then you've got that user right on tap. Yeah.
Absolutely. And you become your own feedback, you sit there and you spot the pain points. It's brilliant. And maybe that's a good excuse for developers to build things in their own time, perhaps. I don't know. Because then you get the idea of, I'm the developer, but I'm also the user. You get that. Because a lot of, I've heard people refer to users with a silent L at the beginning. Because it's like they have no empathy for the user. And I'm like, you don't get it. These are the people who will be paying your wages. Right? They're not paying it directly, but they are paying to use the software that you are building. And so you need to treat them with respect and treat them with empathy. And when they come to you with a problem, you have to just sit there and really think about how you're going to interact with them. If you think it's a simple problem and it is really a case of pepcac, problem exists between chair and keyboard, just don't say that. Just say, well, okay, here's what I think. Obviously, the system isn't designed that well because the process we've designed is you do this and this. But obviously, it doesn't look like that. So let me take that on board. Let me change the system, make it work better. We've always got room to learn. We will get onto the topic in a moment. I promise. There's a person, I've forgotten his surname, but he runs the YouTube channel Linus Tech Tips. And he has recently started a challenge where he would use a Linux-based operating system for a month as his daily driver. And he got into this situation where he'd done something wrong on his computer, and he'd done loads of Googling, tried out 15 million commands without reading what the command does, ends up typing this one command in, and it completely messes up his system. And the lesson to take from that is not, whoa, what a silly user. The lesson to take from that is, how do we get the software to stop you from getting into that position? And when you're in that position, how do we write the software such that it's easy to get back out of that position? Not, oh, look at him, he's done something really silly and he's done it wrong. It's like, no. How do we stop that from happening? How do we put things in place to help him out if he gets stuck. And that, I think, is what all good software design is all about.
That's the really difficult bit of software engineering, in my opinion. I think a lot of people would agree, is it's not writing the code to make the thing do the thing. It's understanding what that thing needs to do. And that's the conversation with the user and bridging that gap between what's possible, and everything's possible given time, but what's possible within budget and what the user needs. And that's the difficult part in software development. And like you say, software is so ubiquitous now. Users use it, and it's your granny using it. It's a bus driver using it. It's people who are not technical, have no interest in being technical. And so the art there is getting software that is self-evident in its use. And it's obvious to, and there is a set of rules, but they're kind of shared and developed over time as more software systems get built, about the common language of software. And that's going to evolve over time as more people become familiar with software, and the current generation have grown up with software, and so they're much more familiar with even simple things like a floppy disk means a save icon, or maybe it doesn't in the future because that's already way out of date. But that common language of design and making design self-evident is really important part, and that's not a software developer's problem, that's a designer's problem.
But then I wonder whether it's the software developer who has to work alongside the designer to help support them in making that happen, right? Because it's pointless having the floppy disk icon, which means save, and when you click it, it doesn't save, right?
I didn't mean to draw. I hate drawing hard lines. Yeah, it's not like but you're right. It's because the designers again are non-technical. Their expertise is understanding user behavior and user experience, and so even if they kind of take up that top half of the relationship between a non-technical user and an API, there's still a gap there to be bridged. And I think lead developers, that their real value and the really difficult part of the job is bridging that gap and making sure. It's the old thing about building the right thing and then building it right. Building the right thing is the hard bit, and then building it right, in my experience, if you've got a solid understanding of the right thing, it's the easy bit.
Totally. So we've talked a lot so far about design and how you design code and stuff. And I've said a few times about agile and things like that. And I think you said clean architecture and hexagonal. We said earlier on, right? You take the bits that work for you. Do you have your own personal description of clean architecture, hexagonal architecture, or whatever that is? I've heard the phrase ports and adapters. I've heard all of these kinds of things. Do you have your own sort of description of how you apply them?
Yeah, so I have a lot of... I'm in debt to Jason Taylor, who's a developer who does a lot of evangelism about how to write software. I think they run a consultancy in Australia. And he kind of... His videos introduced me to this idea of clean architecture. And it's a common idea. It's not his idea, but he's got a certain take on it. And he's got quite a few repos, but one of them is showing how to set up a .NET Core project with an Angular front end using clean architecture. And so I kind of came across that a couple of years ago, and that's really shaped my kind of, as a relative, still consider myself relatively new developer, like a solid way of architecting an API back-end service. That's the first kind of approach to that I've come across that I've really tried, and we built my Bookinghub from the ground up using clean architecture principles based on that, and it's really worked for me. And I think, like I say, the clean architecture, it means a bunch of things to different people, and we're not doing a strict version of that. It's not even what Jason Taylor kind of has. It's about picking the principles. I think for clean architecture, the principle that is the kind of main one for me is that you look at the business domain, and it's a domain-driven architecture, I guess, is the family. It's this idea that the business logic, the kind of crunchy, how the organization do their business, is the most important thing, and it's also really difficult and complex in and of itself. So that's before you start tying it to the outside world through email servers or data storage or a front end. It's about isolating that and saying, right, this is the important bit. Let's give that sole attention and focus and put it in a decoupled environment where it doesn't have to know about these things. And then it exposes interfaces to say, right, I need to know how to save a record. I need to load a record, send an email, look up an external API. And then the layers outside of that then satisfy those interfaces. And that's kind of how I think about clean. It's a layered architecture. It's not. I think clean architecture to me is not a really fundamental difference from a lot of them. It's just a kind of a certain grouping of the common concepts that are around.
Sure, it's like you said earlier on, right? It's a collection of principles that all sort of work together in it's a formula, right? Or a recipe, right? You want to make a cake, you don't go out and figure out how to make a cake. You get some eggs, you get some flour, you get some sugar, get a bowl, you mix it. Of course, unless you're have any intolerances, you then just mix it all together. You stick it in an oven, hopefully in a different bowl, in a more oven specific bowl. 45 minutes later, once the oven's up to temperature, you get a cake out of it. It's the difficult bit then is, what are the other ingredients? Well, okay, so we're a business that makes chocolate cakes. Okay, so how does a chocolate cake work? It's these things and maybe some cocoa and maybe some vanilla. I'm envisioning a core business logic lump that does I take the ingredients, I put them in the oven. But I'm also envisioning like an interface that says, give me ingredients, right? And then it's up to the thing that communicates with that business logic to say, oh, well, eggs, milk, flour, and cocoa, and vanilla. And I don't know why I've got cake on the brain. Maybe it's just because I'm hungry. I don't know. But that's how, is that an analogy that works, or am I way off base?
Yeah, I think... the ingredient that's I'm just getting my head right. But the ingredients are the inputs that you need in order to do your business operation. And the clean architecture for me, the domain is making the cake, and the interfaces are like, where do I get the flour from? Where do I get the vanilla extract from? Where's the oven I put things in? And the business logic is about, in what order do you do those things? And its sole concern is that it doesn't need to know about oven manufacturers or temperatures. Well, it might. Yeah. Take it. How far can you take the analogy? But it might know what temperature, but it just sets the temperature, and the oven stays at that temperature. Yeah.
Or perhaps there's an interface that says set the temperature to this.
Yeah.
But you see, now I'm thinking, do we extend it? And my business logic is now no longer I bake cakes, I bake goods, right? So my business logic is, give me some ingredients, give me a temperature, and I'll bake it for you. Give me instructions about when to rotate it, or I'm thinking souffle, right? Don't make loud noises near it. I don't know whether that's actually a thing. I just know it from cartoons. So how do we get to that stage then? So do I start from the outside and work my way in? Or if we're saying the business logic is in the middle, the domain, I suppose, is in the middle, and we need to provide the inputs, am I working outside in, or am I working inside out, or am I neither? Or rather, how do you do it, I suppose? That's probably the best way to think about it.
It's one of these things that it depends what you're doing. So I think domain, for me, like I said, it's a domain-driven architecture, and that the clue's in the title there. The domain drives the architecture. So in the pure kind of hermetically sealed universe of architectural patterns, you'd say, right, let's start with the domain, and then we'd build the application layer outside of that and build out the way. But in reality, the kind of real-world project I used it for in my Bookinghub, I was doing a rewrite of the platform, and so we already had the bits of code that connected to the email server, loaded data from the database, did the business logic, and it was just more about splitting them out and fitting them in the cubby holes. I think of architectural patterns as cubby holes, rather than starting from scratch and saying, what's the business logic here? Because a lot of the problems had already been solved. It was just about rewriting and creating a clean structure using the existing code. So we didn't start with the domain, but I imagine if you were starting a new project, that might be how you start. And domain-driven design is something I've read a little bit about. It seems a great way of doing that and teasing out the business problems from that kind of inner core first. Because ultimately, I think with systems, that's the purpose. So that should drive what you're doing. It's funny, I often think about systems from a top down, where ultimately you've got a button that a user clicks on, and they don't care what happens when they click that button as long as they get the expected result. So that's one way of looking at it. But also from a technical point of view, I guess it's actually, you've got a software system there, and you need to think about what it's actually doing on a technical level.
Sure. I love to pose questions to junior devs or anyone who comes to me for any kind of mentoring. I say, Imagine you have a button that plays an MP3. Do I, as a user, need to understand how the MP3 starts playing? Do I need to know how the MP3 is split into time sequences and then fed to the audio driver? Then the audio driver for whatever system I'm using will then quantize that, turn that into a sound wave. No, I don't. I just need to know when I hit play, it starts playing. But then what do I need to know if the file can't be found or if the file can't be read? Do I see a horrible, great big yellow screen of death and see, this line of code failed because that line of code failed because that line of code failed? Or do I see a friendly message that says, couldn't find the file, I'm ever so sorry, little sad face? Do I need to have a toggle to turn on the developer message? Do I want technical users to use the system? All of these questions, I feel, go into like the design of a system that we don't really think about. We don't think about these questions because they're sort of hidden away. Don't worry about it. We'll have exception pages whilst we're locally debugging, and we'll kind of turn them off in production, and it doesn't really matter. And I feel like some of those questions get hidden away because, like you say, the abstraction of I push the button, something happens, and magic happens, right? But then actually who needs to decide where that magic lives?
And also, it's never as simple as that. I think that's a recurring problem, is that you've explained even the simple thing, playing an MP3, really, really simple from a UX point of view, but then there's a lot of edge cases and like software, you can easily write something that follows the happy path. It's about the edge cases and the unhappy paths and how you handle them gracefully is such a large part of solid, robust, usable systems, isn't it?
So if I'm understanding what you've said about clean architecture and hexagonal and ports and adapters and all that kind of stuff, if I'm understanding how you have implemented it so far, I could theoretically take a chunk of the business logic that is designed with this sort of clean architecture, ports and adapters-y things, take that out of the system and have that almost as, I'm not going to say microservice because I don't want to hit all of the buzzword bingo. We've said crypto, we've said blockchain, we're going to say microservices. There we go. That's the SEO for this episode. Done. I'm presuming that you can take this one core chunk of the system out that deals with one process, I suppose, and take that out and put that in a service by itself. Is that, I feel like it lends itself to it. Is that the case? Or have you not much experience in that?
That doesn't quite fit with how I would think about breaking down the system, because Bookinghub, it's a monolithic system, and I guess with clean architecture, if you were looking at each service, it would be, in my mind, I've not thought about it, so this is very off the cuff, but each service would have the entirety of the clean architecture. So thinking about like a microservice, it's got let's say a REST API. So it would have all the layers of of clean architecture within that. So it would have the domain logic, the crunchy logic, the application layer, and the infrastructure layer, and you would break it down kind of vertically rather than horizontally. And I think that's kind of maybe something that's quite particular to the way that Jason Taylor's implemented clean architecture, is that it's this idea of the vertical. So it's like a wedge of the pie. So you've got your business operation. Then you've got the application layer that supports that business operation and hooks it up to the infrastructure, and then you've got your endpoint. And one of the ideas I really like about the way Jason Taylor's done it is that you kind of isolate the external facing part of that, so that like the application layer is the messy bit where you tie everything together, but he vertically slices that as well and says, right, for the create booking endpoint, we've got one discrete piece of code that handles that in the application layer, and it's got its own DTOs and its own class that represents the inputs and outputs. And if you come into a system, the way I think about it is you come into a system, you say, I need to make a change in the create booking endpoint. You can go into that folder and you can look at those files and you can play around with them, and you know the limit of your damage is going to be within creating a booking operation. You're not going to have to worry about affecting the update user or the delete booking endpoint. And so he kind of makes that relationship of all the parts in the slice of the pie really closely related, so that you can see what you need to affect and I think in software I always think about what's the limit of the damage I can do here. If I get this wrong, how bad can I get it wrong? And if your scope of your change is within an endpoint, then it kind of makes you feel comfortable that you don't need to test everything else as well. When you're doing some regression testing, you only have to retest the create booking endpoint, and you don't have to worry about everything else.
I like that. In the Pragmatic Programmer, they talk about this idea of tracer bullets. And I dislike the term because it's rather violent, but the idea is that when a gun fires, the rounds fire so fast that you can't see them. But every 3 or 4 rounds, there's one that is lit up, and maybe it's got phosphorus on it, so that you can see where it's going. It's a traceable. It does no damage when it hits whatever, or it does less damage when it hits whatever it's hitting, but it's bright enough that you can see it. So you're not just firing wildly. Again, I don't like this analogy. It's a bit too violent, but there you go. But the reason that they say this is because they say, regardless of whether you're working from the interface of your software down, and I don't mean like public interface, Jamie or whatever. I mean like maybe it's the API or maybe it's the user interface. Whether you're working from the screen to the silicon or the silicon to the screen, they recommend implementing one feature front to back or back to front all the way through to start with. And this has got nothing to do with clean architecture, nothing to do with domain-driven design, but that way you're staying focused, right? And it fits well with what you're saying about if I work in this one specific area today and only make this change here, I don't necessarily or shouldn't have to test everything else with my regression tests because I know I haven't touched it. Those files are all the same. Those classes are all the same. The services, the contracts, everything is still the same. So I don't need to touch anything. I feel like all I'm doing is echoing what you're saying. But what I'm pointing out is that, again, it's all down to principles, right? This principle applies outside, I think, of clean architecture, domain design, that kind of thing, or domain first design, domain driven design, whatever you want to call it, ports and adapters. Can you see I'm doing the SEO thing again? But it fits outside of that, right? Because if you are focused on one specific area, let's say let's go out of the world of software development, right? You are a mechanical engineer and a car has come in to be fixed. You know that all that needs to happen is you need to change a tire, right? If all you do is change that tire, you don't need to test whether you've broken the engine or whether you've somehow wiped out all of the transmission fluid or whether you've somehow shorted the radio. All you need to do is test that tire works. And it feels like it's a perfect example. Maybe not. Maybe I'm being too big-headed by saying it's a perfect example, but it feels like it's an example of what you were saying about that wedge, right? My business is I've got to change the tire. I don't need to bother checking that the airbags still deploy.
Yeah, 100%. And I think that the idea that when you're building software, you work in verticals is really a good one, and it's kind of fits with Agile. Like, what's the measure of progress in Agile? Is working software. So unless you've got that entire vertical working, you've got nothing effectively. And it's something that we think about quite a lot is spiking and getting that kind of just making it work from the silicon to the screen, like you say, just hacking it together and seeing if you can get that traceability, whether that path working. And yeah, I think that I've never thought about that before. Yeah, that fits really well with the way that the project's set up. Is you've got all that code in the application layer kind of in one place. You don't have to worry about a shared like a repository layer, for instance. You just have to write the repository method that exactly matches what you're doing in that one endpoint. Yeah, that's a really, really good point. Yeah.
Thanks. I also like to think of the less code that I have to write, the less code I'm A, going to get wrong, or B, have to debug, right? So going with what you said there, if I'm writing to a repository for my core piece of logic, if I'm only having to implement one method for that repository interface, maybe it's the get widget method, right? I don't need to write a test for my save widget method. I just need to write a bunch of tests for my get widget method, which means that when it doesn't return a widget, I know that something is wrong. I don't have to worry about, maybe it's not saving correctly. It's a very silly example because it's obviously going to be rather obvious to most people that when you're getting something, it's not necessarily the save method, or maybe it is. But you can then isolate that and build your tests, build your system around it, right?
Exactly, yeah. And also when you're building a new repository method, for example, and you're saying, right, get booking, I need a get booking method. Where you're going to use that, where you're using that will vary. You think, oh, it's just a get booking method, but if you're getting a list of bookings, paginated lists, and you're getting like 500 bookings at a time, you don't want to pull every single piece of every column out of the database, and you don't want to join it onto all the price ledger and the customer and customer addresses. You just want the absolute minimal data that's like a summary for that. Whereas if you're doing like get full booking by ID, you're going to join it onto all its records and return that. So the idea, I guess, of separating these endpoints into their own handlers with their own DTOs and their own repository method, if you like, is that you don't have to predict how things are going to be used and shoehorn different use cases into what you're writing. You can say, well, at this point in time, I'm writing this endpoint which needs this exact data, and that's not good enough for now. And it solves trying to generalize things too early in software is quite a common problem. And the rule of threes, I think, is the kind of antidote to that. Is you say, well, don't combine code before you've used it a third time, and then you might have a really good idea of when there is common behavior in the system, real common behavior, not things that just look like they do the same thing. And that's something we've started to do in my Bookinghub. It's getting to be a mature system now, is that we've recognized, well, actually, there's a number of different endpoints that all have their own implementation of this thing. But now we're saying, well, actually, maybe we need to pull them out into common queries, we call them, because we're using entity framework. So the idea of a repository layer doesn't really fit. So we're calling them queries. And we're doing that. So that's about, with the architecture, you're not like tying yourself to this idea, oh, everything lives in that one handler. That's how the architecture is. We're evolving and saying, well, actually, in reality, we've got commonalities, and there's good reason to pull them together now because there's a bunch of complexity there, and we need to unit test it. And if you're having that same complexity in multiple places, unit testing it doesn't really make sense. So we're now kind of maturing and make it really putting our own footprint on how we do clean architecture, because that's not something that's in Jason Taylor's example project. It's not. That's the point at which you really start to progress and make the pattern your own.
There's a really interesting point you made there when you said, I mean, you made loads of interesting points, but there's one that really stuck out to me, which was you said, wait until you've had to do something 3 times. And there is a good argument for dry, don't repeat yourself. But there's also an argument for quite literally the opposite, wet, write everything twice. There is a great argument for that. And Donald Knuth said, I think in the 70s, he said, the root of all evil is premature optimization. And he's absolutely right, because if you spot some code that you think might be used in multiple places, but you've only written it once. It's not, you're doing that single wedge, but you're like, oh, I think this chunk in the wedge might be used in multiple places. I'm tempted to make it generic and start futzing with it now to extend it, to let it be generic, to let it be used by everything else. Well, you've got scope creep there, and it's no longer fixated against that single wedge. And then you're adding complexity, because so generics are great, right? So in C# you can do of T, right? So link is a great example of this. Select these things where it matches this pattern, and they're all of this type of object or whatever. That's fantastic, but it's also rather complex. It's not horrendously complex, because it takes, once you've gotten the idea of how it works, it's brilliant. But also having to write that and then having to test that can be horrendously complex. And so taking some time out to actually think, do I really need to make this generic? I think is a really good idea. Or do I really need to worry about this? If I have to copy paste this one method twice, is that the worst thing in the world? Right? Mm-hmm. Because maybe these 2 copies of the method handle things in such a subtly different way that it's not worth the extra engineering effort, like you say, to throw in some code in there to do type safety and to do checking and to make sure, okay, so it works if you're passing a string and it works if you're passing a double, but if I pass in an int, everything blows up. Is it worth making it so that if you pass in a string or a double, it works, and throwing that check in for the int? Or is it worth just saying, look, we're still in the sort of discovery phase. Doesn't matter. You send an int down there and it blows up. That's your own fault. Or We just wrap that up and log it, and we just tell the user something went wrong. We'll get back to you when we can. Here's a GUID for the problem, right? Is it worth that time? Who can say, right? And like you say, it's all about the principles. It's all about figuring out, is it worth it? What's the cost-benefit analysis, right?
Yeah, I think that's a great point, that you don't want to build these things until you need them. And the temptation when you're writing a horizontal layer is that you kind of build out that before you really understand what it needs to be. And so, yeah, building the vertical, you just focus on exactly what you're trying to do. And the dry principle, yeah, I think it's, and a lot of people say this, it's most misunderstood principle, because it's not about saying don't write code that does the same thing twice. It's about saying don't write code that has the same reason to exist twice. And things can apparently do the same thing, but they have different reasons to exist. If you combine them and say we'll do that in one place, then down the line you realise, oh, actually, they've got different reasons to exist, so they need to start doing things differently. Then you've started coupling things, and you've got problems that come with that. Yeah,
absolutely.
Hey, sorry to interrupt your favorite podcast, but I'm here to tell you about Shrimp and Crits, an actual play podcast with a southern twist. My name is Ian, and I am the keeper for this show as we play Monster of the Week by Michael Sands. If you like the sound of swampy monster mayhem, gators gone shopping, and magical fairy mischief, you will be right at home in the remote panhandle town of Gullah, Florida, where spooky danger has begun to wash ashore. Shrimp and Crits is the story of Sarah Payne the Mundane.
All I'm asking for is answers. That's all I'm looking for, is the truth.
Ari Green the Searcher.
You know the proclamations of the Fae. I suggest you follow them from now on.
And Ray Ray, the most mundane monstrous you will ever meet.
Mr. Zeus, I'm a big fan. I knew you were real. And Ray Ray's just like bowing in front of this swan.
As they fumble their way through protecting their skeptical town from mysterious evils. We release new episodes every other Monday on the podcatcher of your choice. Hope to see you soon in sunny Gullah.
Using the cake example from earlier on, right? You might be tempted to write a thing that takes in maybe you have an interface that is cookable, right? Or bakeable, right? And that is, or I can't think of the right word, but let's say you're kitchenware. There we go, right? And you have an oven class that implements kitchenware, but you also have a microwave class that implements kitchenware. You are very rarely going to put something into the microwave, switch it on for 45 minutes and walk away. But most of the time when you're baking, you will likely do that with something in an oven. You switch the oven on, get it up to temperature, put something in, close the door, walk away, come back 45 minutes later, yumminess has happened. But if you do that with the microwave, I don't know whether you've tried this, you're likely going to end up with a exploded microwave. And so building in the complexity into the kitchenware to handle, am I an oven or am I a microwave? You've immediately, like you said, coupled those two classes together, because the microwave now needs to know about the oven, or indeed the consumer of both of those classes needs to know whether it is a microwave or whether it is an oven, or whether it's a kettle or whether it's a cup, because a kitchenware is an item that you find in the kitchen, right?
Yeah. This is now a game of spot the pattern and principle, but that's like it's in the solid principles, but interface segregation, like that's exactly why you don't do that. You don't put things together that don't belong together, because the consumers, well, I guess there's different reasons there, but it feels like the same thing, that the consumers will then have to the implementer will then have to do things that it doesn't want to do just to satisfy that interface. But if you separate things out, and I guess the thing in the Clean Architect, well, the Jason Taylor's kind of project, not having a repository, you don't have an interface. You're not satisfying an interface. You're just writing some code that does a thing, and you're not trying to make it at all reusable. You're solving that one problem in that one place.
Absolutely. I'm all for writing as little code as possible. I think I said this earlier on, actually. The fewer lines of code that I write, the fewer bugs there are going to be. And that's not meant to say, oh, Jamie's the worst at writing code. It's the same for everyone, right? The fewer lines of code we write, and I don't mean like make it really complex and have multiple link statements on the same line. I mean like there is a reason why the principle of no more than X number of lines of code in a method exists. And that's because you are making that method do one thing It's what I call the Charles Emerson Winchester effect. For the people who are old enough to have ever watched MASH on TV will get this. The very first time you meet one of the characters called Charles Emerson Winchester III, he says, "Gentlemen, I do one thing at a time. I do it very well, and then I move on." And that's the whole point of making methods that are very small. It's not to be really clever and to use lots of different angle brackets in different places. It's so that the method does one thing, and it does it perfectly, or as close to perfectly as you can get, or for a given value of perfect. Using a .NET example, string.is null or empty doesn't do anything other than tell you whether the string you passed in is null or is empty. It doesn't go to the database. It doesn't go over the network. It doesn't do anything to do with numbers. It literally doesn't tell you how long the string is. It just tells you, is this string null or is it empty? In the same way that with a string is null or whitespace. All it does is it tells you whether it's null or whether it's got any kind of spacing characters in, and that's it. It does nothing else. And that's where this idea of making things smaller and writing those small methods comes from. Because the fewer lines of code that there are, the fewer bugs there are going to be.
And making it easy to understand. The grokability, I don't know if that's a word, but if you can look at something, if it's more than 10 lines, you get bored by the end of the method. But yeah. And looking down the line, it's something I think about from the start. Is another reason to segregate your interfaces is if you've got a really simple operation, then when you do come to optimize it, then you can optimize that easily because you're doing one thing. But if you've got a complex method, then you can't easily make efficiency gains there because you've got a whole number of inputs. Your inputs could be anything, and you have to deal with all those cases. So an example from my Bookinghub, for example, in the low service layers, we've got a service that takes a range of postcodes and finds out the travel time between them. And the mapping service that we hook into will take a matrix. So it'll take lots of start sources, they call them start points, and lots of destinations, and give you the whole matrix of all the journeys between them. But I kind of realised that if we want to optimize that's quite a really complex thing to optimize. So maybe we simplify it and we say you can only have one start and lots of destinations, or one destination and lots of starts. And that actually worked for the way we use mapping within the system. And so we wrote the interface that wraps the mapping service to have that interface. And then down the line, when we come to optimize that, it's a much easier problem. You've only got a row of values or a column of values, not a matrix to deal with.
Sure. Knowing that you have this service and you have this business entity that needs to know the answer, it allowed you to make that call, didn't it? It allowed you to go, right, look, it's going to be no good to do this with a matrix. We have to do it with a row or a column. As you said, one start and multiple stops, or one stop and multiple starts. But because you knew about the domain, you would know that there is perhaps no need to do multiple starts and multiple stops, because the domain logic, the business logic, the rules that you are trying to implement in the code say that, hey, in our business, we don't have multiple starts and multiple stops. One of one and multiple of the other, or rather, one of one and one or more of the other. You start somewhere and you may stop along the way, or you may stop a bunch of ways. It makes sense there, because then you didn't then spend time figuring out how to represent that matrix and how to optimize for that matrix, because there was no need to, because the business said, we don't need that. And I think that's one of the hardest things that developers have to sort of learn as they sort of go through their journey. It doesn't matter where you are on that journey. I am convinced that no matter where you are on your educational journey in software development, software engineering, coding, programming, whatever you want to call it, we can all learn something every single day. And I think one of the most important lessons is from one of the Alice in Wonderland books. And the king said, start at the beginning, come to the end, and then stop. And that's what you need to do. You need to write enough code to solve the problem, and then stop writing code. Pencils down, tools down, and then figure out, can we change this? Do we need to change it? Does it solve the problem? Not to use an example from my own past. I once wrote an API to allow me to sort of deal with my video game collection. I'm a pretty big video game player, pretty avid collector, and I hooked into several different services to get lots of information. And I started with, okay, so I'll need an API that can do create a record, read a record, update a record, delete a record for games, users, ratings, images. And no, what I needed to do was store a game in the database, right? I didn't need to do all of this fluffy stuff around it. Create a record. Done. Right. Fantastic. That's my section of the code. That's my tracer bullet done. But I didn't. I sat there and wrote out a huge API. Afternoons were wasted just building up, controllers and actions, not getting anything done because there were stub interfaces. And it was just like, yeah, poke at this, it will throw an exception, but I know that the API exists. Because then I could build a user interface. And there's nothing wrong with starting at the screen, going down to the silicon. And there's nothing wrong with starting at the silicon and coming up to the screen. But you need to, like you said, you need to find the core rules of the business thing you're trying to implement and then tackle them one at a time. Because then you're not, you may even find you can lean on no code or low code. Why not?
Yeah, I think the way I think about that is developers, the temptation is to solve interesting problems, but actually you need to solve the real problem that the customer has. And sometimes they're not interesting. And if your code feels simple and you've solved the problem, then you've done an excellent job. And move on. No, don't wonder what complexity you might add.
Yeah. I forget the engineer's name, but there was an interview that I listened to on the DevSecOps, one of the DevSecOps podcasts. And this engineer said that they were talking with one of their junior engineers, and they were saying, "Oh, we need to build this, we need to build that, we need to put loads of feature flags into the app because we may want to turn this on." And this senior engineer turned around and said, "We haven't even built that feature yet. Why do we need a feature flag for it? What are you doing? You're adding code to load feature flags for features that don't exist yet. You're adding complexity before it's required."
That is something that I quite recently have been bumping up against a few times, is writing code in a pull request, the unit of code that most of us work in, that is not related to the thing that you're solving. It's looking down the line and saying, we'll need to do that later. And I think it's a cliff edge. It looks like there's nothing there, and then you just go, and it feels like, oh, what's the harm that can be done in that? But so many times I've seen it. You write some code and you think, oh, we're going to do that, and then that feature gets cut, and you're not doing that anymore. And then you've got this dead code that's just confusing in the system. It's like, well, why does that exist? It's not called anywhere, and it's quite a strict rule. I have very few kind of hard rules. I have one hard rule, but that is one that I'm pretty firm on, is that if it's not actually solving the problem we're solving right now, it doesn't get into the code base.
Absolutely. You need to think like a rocket engineer. If I'm going to build a rocket that's going to go to the moon, I need to only put the things on the rocket that will get it to the moon, and only the things that it will need when it gets to the moon, because I have a physical constraint of how bulky and how heavy this thing can be. The heavier it is, the more fuel I need to burn to get it off the ground. And if I'm burning more fuel, that means A, I'm producing loads more greenhouse gases, if that's one of your problems, and B, it's costing a shed load more, because guess what? You got to buy more fuel. And then if the thing crashes, and I don't mean like a software crash, like it bends over and explodes, all of that money and all of that time was wasted.
Yeah. I think on the writing more code, I think that the principle, I've heard it before, is that all code is bad code. And it sounds like a trite kind of trivial thing, but I think it is I think it's got a lot of truth in it. And the more code you write, the more, like, if you can avoid writing code, and like say with the caveat that making things terse and short, like fewer characters is not more code, it's something more subtle than that, then you should, yeah. And it's I think people have a tendency, and myself included, say, oh no, I can write good code, I can write clean code, but no, all code is bad code, and if you don't have to write code to solve a problem, then don't. And the low code, no code options, like they're going to become more prevalent as we. Why write custom software why reinvent the wheel if you don't have to? And it's not appetizing to a software developer to use a pre-built solution, but it's sometimes the right thing to do.
Yeah, I mean, I can count on one hand, maybe two, the projects that I've worked on the last 10 years that are not read something from the database, display it to the user, let the user make some change to it, transform it slightly, and put it back in the database. That is 90% of the bread and butter of stuff that I do. And it will likely be maybe not 100%, maybe not even 90%, maybe 70%. Maybe you're the lucky ones who work on super interesting things. But I will guarantee that a large percentage of what we all do as developers is get the user to type something in, transform it, store it in the database, pull it back out of the database, retransform it, show it to the user. It's forms over data is important for a reason. The majority of businesses work like that. And you will fall into areas where it'll be slightly more interesting than that. But guess what? The data's got to go somewhere. It's going in the database. And it can't just go in as it is. It's got to be transformed before it goes in. So you're still working on that forms over data, you know?
Yeah. The kind of flip side of that is that you always think, you should be able to generalize these problems and why aren't there more kind of general solutions? But when you dive into specific business requirements, that complexity kind of pollutes that, and you end up thinking sometimes, you have to write custom solutions, and it's about finding that level, like what you can write custom versus what you can integrate with the existing solution, and that tension between, well, if you pick an existing solution, it's not going to be 100% perfect for your requirements, probably, but it's 90% perfect. And if you can use that thing and make do with not having that 10%, then there's a massive benefit of not having written the 90%. Mm-hmm. But quite often you think, it doesn't do this one cool feature that I need, and so I'm not going to use it. I'm going to write the whole thing myself, which, it's not very economical.
Yeah, I feel like a lot of... I see this more with junior developers. I feel like I'm picking on junior developers now, but I see this more with junior developers of, like you say, it doesn't solve a large enough percentage of my problems, therefore I'll do it all myself. And I'm like, okay, right. This cryptographic library that does, I don't know, TLS or some kind of HMAC, that does some wonderful funky maths and you get a number out, that doesn't do everything you want. So you're going to go write your own, are you? Even PhDs don't write their own crypto for a reason.
Having worked in like blockchain security software, that is one of the golden rules of cryptography, is you don't write your own. Mm-hmm. And that's not for a wasted effort thing. That is security and peer review. It's just impossible to write software in an isolated room that is proven to be good. You have to get it out in the wild and test it. So we need to focus effort around the open source and the shared software for doing things that are super critical, such as cryptography. Yeah.
Sure. We talked a little in our pre-discussion. So for people who are just listening in, if you want to be on the show, do get in contact, and we'll have a call and we'll discuss what it is you want to talk about. You mentioned in passing this thing called subcutaneous testing. I was wondering if you could discuss that a little bit, and then when we're done with that, we'll talk about, you've brought up my Bookinghub a lot. Let's talk about that as well afterwards, right? So I know that subcutaneous means under the skin, and I know that testing means you're testing. So I'm testing under my skin? What's that all about?
Yeah, so this is another idea. I'd use a softer term than steal, but Jason Taylor basically has a sister repository to the clean architecture one that's clean testing, and in his videos he talks about this idea of subcutaneous testing. I don't think it's his idea, but he is where I found out about it, and it's this. The idea is that you've got the testing pyramid, which I think a lot of people will be familiar with. You've got your unit testing at the bottom, which are small, isolated tests that are really reliable, easy to write, but don't give you confidence that the system works as a whole. And then up at the top, you've got end-to-end tests, I guess, at the very tip, and they're about flexing the whole system, including database and even the UI. And they are super hard to write, flaky, hard to maintain, but they give you a really high confidence. If they're passing, then your system is holding together and working as expected. And I guess the idea of subcutaneous testing is you're kind of chopping the top off that pyramid and saying, well, if we can reduce some of that flakiness, which is from the kind of user interface, if you like, and duck under that, and then start our test at the point that we've got a bit more of a level playing field, then it's a bit of a sweet spot between assurance that the system's working as a whole and like maintainability and ease to write. So the subcutaneous tests in in the clean testing repo. It's about an API. So your end-to-end is like a REST request going into the system. It's not got a user interface. And so the subcutaneous test kind of in ASP.NET Core, if you imagine you duck under the request handling and the authentication and validation, and you go to the point where you've got your DTO that's been passed in and deserialized, and then you test everything else down to the database and back. And so that was kind of how we set out testing in my Bookinghub. So we don't have end-to-end tests, but subcutaneous tests. And it's a really powerful idea that gets you off the ground quicker, but we're actually thinking of moving away from them now, because the drawback is that you're ducking under the authentication and validation, and so you can't test those things. And so the question is, do you test those things separately, or do you test them kind of in isolation? But my feeling is that if you've got unit tests around authentication and validation, that's great. You know that the code that does that is working, but you don't have an assurance, like an automated assurance that is working in the production system. So although it was an interesting path to go down, I think on reflection, end-to-end tests probably are preferable, and I think we'll move towards that going forward.
Sure. What I'm taking from that is something I already knew, which is testing is hard. Right? It's not easy. And that's not just test-driven development or development-driven testing. I think it's called characterization tests or behavior tests or whatever, right? Getting that balance is really hard, because you could get, you said earlier on about, you those end-to-end tests right at the very tip of the pyramid. They're very flaky, but they test everything, assuming that you're asserting something. And you could say that about any test, right? But I've literally seen enterprise-level code bases where they focused on code coverage, right? It's got to be code coverage, it's got to be 75% or higher, or 90% or higher. And my personal yardstick is 60%. If you're going over 60%, you're wasting your time. Because at that point, you're testing framework code and you're testing the placement of braces, right? Maybe I'm just cynical, I don't know. But what I found is when there's this difficult balance to strike against actually writing an actual test that asserts a bunch of stuff and proves something correct, and hitting this impossible metric. And what I've found is, in teams where they're edging more towards the impossible metric, they never assert anything. I've seen tests that if you threw an assertion in, it would fail. But because it touches all of the code, doesn't matter. Hey, we've achieved the goal. Well done, lads. We can go home. We've achieved the goal of 100% unit test coverage. But then, like you say, it's like, at what point do we go from a unit test into an integration test? And at what point does it go from an integration test to, maybe like you said, a subcutaneous? And then from subcutaneous, how do we go from subcutaneous to end-to-end? And then, like you said there yourself, testing that authentication. You may have a unit test that tests if I give you a bad username and password, a known bad combination, it doesn't let me in. Does that unit test also cover if I set up a user with these permissions and I send this request in? Is that a unit test? Is that an integration test? Sometimes it's difficult to find where on that pyramid your test sits. I think the only way to, in my opinion, to sort of answer that is to write your tests as part of the specification. So like if you have a user story, let's say you're using user stories and it says, as a user, I could push a button and it will play an MP3. Okay, right. Let's write the test cases into this piece of work. User presses button, there is an MP3. You can even go granular and say there are speakers attached. The volume is turned up. The person can hear, right? What about accessibility issues? Does the test pass if the person is deaf? Are we testing whether they can hear it or whether it is playing? That's me being really, really, really over the top and specific. You may think a stupid example, but where in that list of questions do we stop? And do we class that as fully tested or not? If we can say that when you push the button, it plays the song, but the person can't hear it. Well, is it because they are hard of hearing? Is it because there were no speakers plugged in? Is it because the application can crash and be playing in that there is data streaming to the audio driver, but the audio driver isn't working? Is that a pass or is that a fail? Is that an end-to-end test? it's a silly example because very few people who work in sort of web dev are gonna have to deal with that kind of granular level of activity. But I find that sometimes it's better to have a silly example rather than spend hours thinking of, because I come up with all of these examples off the top of my head. I don't know what I'm saying.
Yeah, there's so many interesting points there. One, the enterprise people who were writing tests that didn't actually assert anything. I don't know if they're doing that deliberately or not, but I mentioned earlier, like, I've got one golden rule, and it is like an absolute hard rule that I try not to break ever, is that I always see a test failing before I, at some point. Even if you write the test with the code, I always break it so that I can see it failing and check that it's actually doing something, and preferably doing, like, failing in the expected way, because there's so many ways that you can rig tests. A classic one in NUnit is you forget to put the test attribute on it, and then it just doesn't run as a test, and you won't get an X. But if you're not sharp eagle-eyed, you won't see that the test is missing. So, yeah, and tying together the different layers of testing, so the end-to-end versus the integration versus unit testing, I think something that I really struggled with, and I'm just starting to shape in my brain now, is I think of it like unit tests are the kind of a mass around the feature that obviously they're really rich, and they kind of flex the edge cases, and they kind of they're very specific to that one feature. And then the integration test, you're kind of sending a probe down and making sure you hit something within that unit test, that group of unit tests. And that kind of ties the two together. That's kind of a bit of a weird mental image maybe, but if you've got an edge case in your unit test that says maybe your password can't have an @ symbol in it, but it can have an exclamation mark. If you write an integration test that tests that the @ symbol isn't that fails in the expected way, then you know that your complex logic is there. And if you know it's there, then it's being tested by your unit test, because you can't write your integration test every single permutation. And it's thinking about how you concretely tie up your integration tests with your unit tests.
Absolutely, I agree. Like I say, it's a complex problem to solve. And on that example that I gave about tests without assertions, I've also seen entire test classes that are commented out. Like it says public class test whatever, squiggly brackets, and everything in between it commented out. Because there is a unit test for it, you know. I have seen all the excuses not to write tests and to write tests.
Yeah, something that I've heard about but not looked into myself is that prevents like rigged tests. I don't know if you've come across this, but it's mutation testing. And the idea is that the runtime, the package that does this, I think it goes into your actual source code and flips the conditions within your source code, and then checks that the tests fail. And then that way it gives you a high assurance that your tests are actually doing something. And you can automate that. Seems like a powerful idea. I don't think it's quite like taken off, but there's libraries that'll do it for .NET.
Yeah, it's I've looked into a few. It's that cost benefit analysis, right?
Yeah.
You need to figure out whether it's worth investing that extra engineering time to do that test. If it's for something, I suppose if it's for something in your core business logic, that is, if this breaks, we lose $1 million. Yeah, you want to do all the testing. You want to do mutation testing, end-to-end integration, all this kind of stuff. But if it's for when the user selects, I want my profile picture to have a yellow background, it's probably not as important, right? It is important to that user, but to the overall business, not so much.
Yeah. And I think the way that I work around that risk is that, like I say, it's my golden rule. I try not to commit tests that I haven't seen failing for the right reason. And if you do that when you write the test, then there's a low risk that your tests are not working.
Okay, so to tie all of this discussion together, we were talking again in this pre-interview call about how you'd used all of these techniques and loads more, and all of these principles and loads more, to build a project that you're working on called My Bookinghub. Let's just sort of quickly talk about how they all sort of fit together when you were building that, what My Bookinghub is, and just discuss that for a few minutes. So I guess first off, what is my Bookinghub? And then secondly, you talked about all of these different architecture patterns and all the different testing patterns. Did you use all of them, or was it more a case of, hey, I know about this thing, but we're not going to use it because it's not relevant?
Yeah. So my Bookinghub, this is kind of, I've got a book out bit, isn't it? So Bookinghub is our booking platform that we've built, and there's lots of booking platforms out there, but our kind of USP is that it's for mobile services, and so it's about people who deliver services to customers at their home or their office or wherever that location might be. And what we do is we use mapping software to understand where the customer wants an appointment and where the service providers currently have appointments booked and where their home base is. And then we offer the customer slots that they could have their desired appointment on based on that. And we do that in an efficient way, which is kind of a win-win-win, where the customer feels like they're doing something good for the environment. The service provider's got a dense diary and they've got lots of appointments, and also they're driving less miles. So, like I say, that's good for the planet. We kind of build that in partner with one of our customers and a car valeting service, fresh car valeting, and we're looking to roll it out to other service providers. So electric charge point installers, believe it or not, is one of our kind of potential markets. Yeah, so it's there's a website in the show notes, so if people want to check us out, then they can click there and find out about it or get in touch. And on the second point, so how was my Bookinghub? What does it use in terms of all these ideas we've talked about? I think the key one was the clean architecture kind of structure, project structure. So I kind of borrowed a lot, like I say, from Jason Taylor, his clean architecture, and set up the kind of 3 layers which he describes. So the domain layer, which has 0 dependencies, and it's this crunchy business logic we talked about that is complex and important in itself. The infrastructure layer talks to the external world, so it connects to the database, it sends emails, it handles HTTP over REST, and then the application there fills in the gap, so it hooks up the domain to the infrastructure. So that was kind of bedrock that we decided on very early on in my Bookinghub, and it stood the test of time. When we've had new features come in to be developed, I've never had too much difficulty in understanding how it breaks down into those parts of the application, into the architecture. For instance, the algorithm, the kind of crunchy bit that does the clever appointment suggesting, one of the problems with the existing system when we rewrote it was that was quite strongly integrated with the database, and so to test that you had to hook it up to a real database to write any tests against it. But with clean architecture, it became obvious that making it 0 dependency is what we needed to do, and that would go in the domain. And so by making the algorithm 0 dependency, it makes it super easy to unit test. You can just fire in models at it without having to worry about database connection, and give us a high coverage in that. We've tested all the edge cases and the complexity of that. So that was a really important decision, and I think it's allowed us to understand going forward when we've continued to make changes to the algorithm and improve it.
Excellent. Okay. With all that said, if you were to give some advice to someone who wanted to either create from scratch or rewrite a system using some of the techniques we've discussed today, the different types of architecture, whether it's clean, hexagonal, monolithic, microservices, whatever, and all the different types of testing we've talked about and all the different things that you've talked about with my Bookinghub, do you have maybe 2 or 3 pieces of advice you'd give to someone who's looking to do that, to sort of start from scratch? And are some of those pieces of advice, go watch this video, go read this book? Or is it more a case of, hey, just make sure you get the fundamentals right before you start? What are some of your pieces of advice?
Yeah, I think going and reading, looking at the repo from Jason Taylor, and he's got many videos online. I think can't stress how excellent a resource that is, and so that would be advice number 1. And I think the only other bit of advice I would give is consistency over correctness. Once you've picked an approach, try and stick to that, and don't get lost in, we can make this better and we can do this thing differently. Try and set your principles early on and then stick to them and then concentrate on building out the system using that architecture and those principles. It's very attractive to think, like 2 months after you've started your project, a new validation library comes out, or you find there's a better way of doing validation, and so you start writing validation in a different way, and then people coming into your project to see the same thing being done different ways, and it's really hard to understand what's going on. And I think something I keep on coming back to a lot recently is consistency over correctness. It doesn't matter if it's the best way of doing it, but if it works and it's the same as everything else, then people can understand that, and it saves the hassle of just looking at code and thinking, oh, I can't understand this, I'm going to have to sit and go through this and load it all into my memory before I can start to do anything. If the code's laid out in an expected way and it follows patterns, it's so important.
Sure. And it saves on context switching as well, right? So if there's a chunk of code, if there's one of these pie slices that does things a certain way, and then you finish the work on that pie slice, maybe you're implementing a feature or fixing a bug, and you jump to another pie slice to do some other work, and it is the same code base, it is talking to the same business logic area, it's filling in the same gaps with the application area, it's still got those connections to the outside where the same things are in place, but everything works completely differently. Maybe, like you say, you're doing validation differently, or maybe it's a different type of authentication, or maybe it's a different database for no real reason other than it's a different database. Not like, I'm not getting at like, oh, well, this bit's in ASP.NET identity because that's good fit for this project, and this bit is in whatever. I mean, just like completely different, right? This bit of the code talks to Oracle because the person who wrote it had an Oracle license and is safe with doing Oracle, right? The problem there is, like you say, you've got this context switch. When I come to work on that second chunk of code, I have to A, get an Oracle license, B, install loads of software, and then C, before I can even do that, I need to understand what the code's actually doing. So you're absolutely right. I think consistency is more important, because then you've got almost like a common language in the team. The whole idea of domain-driven design is that you write I'm probably going to mangle this. I'm trying to sort of reduce it a lot. You write the program and the logic such that it fits the domain of the problem and uses that common design language. We talked about it earlier. And then if you are doing things the exact same way, almost like coding standards, using the same libraries, using the same sort of setup, then the only thing you're switching on is the part of the problem that you're solving. Not, oh, and this bit's written in VB, or this bit's written in Go, or this bit's written in, there is scope for that in other projects. But if you're working on a single project that is, and I'm not trying to say that my Bookinghub is a small project, but if you're working on a single project that has this pie slice idea, this vertical design, verticals. I always get vertical and horizontal the wrong way around. Always have done my entire life. But if you've got this vertical design idea, this pie slice idea, then you would expect jumping between the pie slices, a lot of it to be not the same, but very similarly put together, right?
Yeah, and it's on a really fine-grained level as well. It's not just about different languages and different database tools, but different naming and different structure, linting on the code. I think linting, people will laugh and say it's linting, like focus on the important problems, but I think linting can actually make a code base much more readable, because anything that's different in a code base catches your eye. So in JavaScript, like, semicolons are optional. But if half the files have, or some of the lines don't have semicolons and some do, that catches your eye. And it doesn't matter in 99% but it catches your eye and it distracts you from what does matter. And so I think tight coding standards are important. And developers, maybe think it's part of their identity is how they write code, but I think it's one of these things that's really about the team. It doesn't matter how you do it a lot of the time. It's about having that shared way of doing it. It should be a consensus, but then consistency over correctness. You do it that way. You don't waver from that for no good reason.
Sure. It goes back to that idea of what works for the team, right? For instance, a friend of the show, Zach, he says, I've had my last argument over linting. I've had my last argument over where the braces should go, and where semicolons go. for context, he used to be a JavaScript developer. He's now moved to Python and things like that. He's had his last argument to do with that because the linter will take care of it for him. He's got his IDE set up, so he hits Control S, and the coding standards are applied for him, so he doesn't have to remember. So if his personal I am writing it in the flow coding standards are that he doesn't put semicolons on, he knows that when he hits Control S or Control bang QW or whatever, because he's a Vim user, he knows that when he exits out of that file and saves it, the linter will step in and do the bits that, put the semicolons in, rearrange how, put the brackets here and put this, that, and the other. And then he doesn't have to think about it. He's done the hard part of translating his thought into the syntax for the language. And then the tool comes along and sort of prettifies it. I don't want to reduce that, but it puts it into the right coding standards for that team that he's working alongside of. And I think it's a very important thing to mention. I think things like editor config and linters are so important, and most of the IDEs hook into these things and will do it all for you. And so I think it's a great idea. I think you're right. I think consistency, not just like you say, not just the libraries we use, the way we write it, but actually how the code looks when it's loaded into your IDE, when you're looking at the characters. That's as important too. I like it.
Yeah, you say Prettify, but that's actually the name of the tool. Like a common tool is Prettify. The name of the ticket was Prettify on save. We actually put that in the front end recently, yeah, so that we get that functionality. It's just modern tools like devs doing dev tooling for devs, and it's so beneficial.
Yeah, excellent. I like it because then it's similar to what's it called? Like Babel and things like that. So you can write whatever version of JavaScript you want, and it will get transpiled down to a version that you're targeting IE. So you write it with the arrow syntax. I'll take care of the difficult bit of doing all of that wiring up for you, so you don't have to worry about it. And yeah, it's the tools. If the entire team writes with the arrow syntax, but then you have to target IE, you're going to have problems. But if you have a tool that sits in between and sorts it out for you, fantastic. You've got that consistency. It doesn't matter if it's correct or not. You've got that consistency. I like it. So, Matthew, right, as we come towards the wrapping up, how can people get in touch with you? What was the URL for my Bookinghub again? And do you have any sort of top resources you recommend? I know you've said a lot. You'd say go watch Jason Taylor's videos and read some of his posts. Are there any others? That kind of thing. Just like, let's help spread some knowledge,
Yeah, for sure. So I don't actually, it's one of these things, I've not got around to a website which people can contact me, but like LinkedIn, fire me a message and I'd be more than happy to elaborate on any of the things we raised or just hook up with people. Yeah, Jason Taylor, his GitHub handle is Jason Taylor Dev /Clean Architecture. Hopefully that'll be in the show notes as well. I think a completely different style of resource, but one that I always go back to is there's a website called The Morning Brew by Chris Alcock. And it's just a really good distillation of things that have been happening, kind of .NET, Microsoft focused with a little bit of React and Angular. And every weekday he posts around 10 articles that just give you a flavour of what the most recent things are. And anyone in the office who's like, oh, they knew the version of .NET's getting released this week. How do they know that? One way you can do that is just hook into The Morning Brew.
I have to say I used to use that quite a lot. I would, on the train into work, I'd be on the phone, read through a few articles, bookmark a few, get into work where I used to work. As soon as we hit Slack, right, guys, you got to read these 3 articles because they're amazing. And none of it is related to what you're doing, but hey, check these out. This is where the industry's going, or hey, there's this cool new feature coming to Xamarin or whatever. It's a wonderful resource. It really is. So yeah, I can recommend that too.
Yeah, I'll give you make sure the link's in the show notes.
Oh, absolutely, yeah. Everything we've talked about will be in the show notes, so people don't. I have to make this joke about so you don't have to. If you're driving into work, you don't have to dive over the dashboard to hit the pause button, so you remember the time code for when you said it or anything like that. Everything's in the show notes, so don't worry about that. But yes, I guess Matthew, all that really remains to say is to thank you ever so much for being on the show, and to thank you for sharing your knowledge. And I hope that lots of people go check out my Bookinghub and get in touch with you on LinkedIn.
Thanks very much, Jamie. It's been a pleasure. Always like talking tech.
Excellent. Well, thank you ever so much. That was my interview with Matthew Jeorrett about the clean architecture and subcutaneous testing. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .netcore.show/subscribe for ways to do that, or to reach out via our contact page at .netcore.show/contact. And obviously to come back next time for more .NET goodness. I'll see you again real soon. See you later, folks. The .NET Core podcast is a production of RJJ Software Limited.